we do some revision for the Pythagoras theorem. So for the Pythagoras theorem, we must have a right angle triangle. Okay, so we know that opposite of the 90 degree is the longest. Okay, it's the longest. Okay, we will call it hypotenuse, but over here I will say it is the longest. Okay, so the other one will be shorter than the hypotenuse. So according to Pythagoras, it says that the longer side is the sum of the square of the other two shorter sides. Okay, so if we want to find the longer side, then it will be the square root of the sum of the square. If we want to find the short side, then the short one is the longest one square minus the short two square. Then if we want to find the short side, it will be the longest side square minus the short side square. So to remember this Pythagoras theorem, okay, I will tell the student, you imagine we have a house. Inside a house there is two persons. To find the longest one, we do the sum, and to find the shorter one, we use the minus. So we can have a few examples here. So let's say I have the 3, 4 here and want to find the x. So we can have the x squared equal to 3 squared plus 4 squared. That is the 9 plus 14, 16. Then it is 25. So the x will be the square root of 25. It is 5. So actually we no need to do it this way. We can just write the x. Since the x is the longest side, then we can have the square root of 3 squared plus 4 squared. Then straight we get 5. Okay, we can use the calculator. Square root of 3 squared plus 4 squared here. Then we get 5. Okay, but actually I don't need to use the calculator. So next, if we have a 5, 13 here, we want to find the value of x. So we know that the 13 square will be the x squared plus 5 squared. So 169 minus 25 will be the x squared. Then the x squared will be 144. So x will be the square root of 144, then it is 12. So we know that this is the longer side. So we want to find the x. So we have the square root of 13 square minus the 5 square, then we have 12 here. Okay, so you can have the calculator, square root of 13 square minus 5 square, then we have 12. Okay, so from here we know that we no need to we don't need to actually we can so we no need to write very complicated. Okay, we have few more examples here. Let's say we have 18, 15, and then this is the x. We know the x is the longer side. Then I can find the value of x by using 8 squared plus 15 squared. Then I will get the answer is 17. And let's say I have this one. So we have the 9 and then 41. This is the y. So 41 is the longer side. Then the y will be the square root of 41 square minus 9 square. Then we have 40. Okay. Okay. I can get the answer without using the calculator. There is the reason. Okay, because in the Pythagoras here we have the triples of Pythagoras theorem. So what is the triples of the Pythagoras? Okay, so there is some number that always come out in the Pythagoras theorem here. We have the 3, 4, 5, and then 5, 12, 13. Then we have the 7, 8, 9, 8, 15, 17, 7, 24, 25, 9, 40, 41. Okay, so all of these are the triples. So you can see that I have the square root of 3 square plus 4 square is 5, and then square root of 5 square plus 12 square it is 13, and then square root of 7 square plus 24 square it is 25, square root of 8 square plus 15 square is 17, and the square root of 9 square plus 40 square it is 41. Okay, so this is the Pythagoras theorem, the triples, and their multiples. So 2 times 5, 10, 24, 26. We have the 6, 8, 10, 9, 12, 15, 12, 16, 20, 15, 20, and 25. Okay, so this is the Pythagoras triples. Okay, so we need to memorize this Pythagoras triples, then it is easier for us to solve the question that involve a right angle triangle. So this is the Pythagorean triple. Okay, so this is the Pythagorean triples. Okay.